Okay, let's look at this question. This tree, to stabilize the tree partially uprooted in a storm, cable AB and AC. Cable AB and AC, okay, are attached to the upper trunk of the tree and then are fastened to a steel rods anchored. You can see that there's an anchored here, okay, in the ground, knowing that the tension in cable AC is 810. So he gives you the cable tension here, AC 810. And determine what is the component of the force exerted by this cable on the tree. So he wants to know the force of this cable on the tree. Look at this. This is the three-dimensional. This is the z-axis, this is the y-axis, and this is the x-axis. And he wants this cable AC. First of all, you can see that the floor, it is the z-axis and the x-axis, and the y is perpendicular to both. So now, first thing, we have to make this one, if you make it down to the floor, which means down to the x and z plane. So if you make this cable cosine 45, if you make it cosine 45, it's going to be in the xz plane. So you know that it's 810, AC is 810. So we'll do force of AC, which is 810, cosine 45 in the xz plane. And then look at this. If you want to make it, it's going to be here then. It's going to be here. Cosine 45 is going to be here. And then it's going to be cosine 25 to make it in the z. Okay? So the force AC, cosine 45 to make it down in the xz plane, and then cosine 25. So FZ, F cosine 45, cosine 25. F, the force in the z-axis, the force. The force is 810. The force, he told you, it's 810. So he gave you the force AC. So the force, 810, cosine 45, cosine 25, this is the force in the z-axis. So, cosine 45 in the xz plane, and then cosine 25 in the fz. Now, what is in the x? Okay, in the x, you can see that it is, when you bring it down, cosine 45, okay, this is in the x, cosine 45 in the xz plane. Now, cosine 25 in the z, sine 25 in the x, okay, and it's going to be sine 25 in the minus x, so it's in the, this is the positive x. Now we are talking about cosine 45 in the xz plane, cosine 25 in the z, and sine 25 in the x, in the other side of the x. So F cosine 45 minus sine 25. And we know that the force is 810. So 810 cosine 45 sine 25 is minus 242.06 pound, because he gives you the force in pound. And Fz, as you said, F cosine 45 cosine 25, 810 cosine 45 cosine 25, that's 519.1 pounds. Now let's look at Fy. Fy, you don't have to make it cosine 45 down, because it is in a different plane. It's when you make it cosine 45, you make it xz plane. Now, you should make it the other side, not cosine 45, sine 45. So, and the sine 45, going to make it in the negative y. So, the force, sine 45, negative. So it's the force is 810, it doesn't change. Sine 45, so it's minus 572.8 pounds. Now, so these are the forces. These are the component of the force exerted by this tree. Now, what is the angle theta x, theta y, theta z that the force forms with the axis at A, which are parallel to the coordinate axis? So what are the components theta x, theta y, theta z? This is very simple. You go first of all for the fx, because fx is equal f cosine x theta x. This is by default. Theta x, fx is equal minus 242.06. So we put it like this. The force is given 810. Cosine theta x. Now you know cosine theta x is equal this divided by this. You will get that, and then you will do theta x cosine inverse of that number. You will end up with 107.38 degrees. You'll do the same thing for fy. if y is equal f cosine theta, y. If y is given from the previous equation minus 57.75, okay? And f is 810 cosine theta y. You have to put the minus because otherwise you're going to get another angle. Theta y is 135 degrees. And last one, fz, f cosine theta z. Fz was given here equal to 519.1. F, which is 810 cosine theta z, and then you do the cosine theta z this over this, and then you find theta z cosine inverse of the whole thing. Theta z is equal 15.14. Okay, thank you.